solving right angle triangles. There are a couple other rules we can use, but these basic ones are the most efficient ways to solve right angle triangles, and they're usually known as Sohcahtoa, right? And the way it's set up is they call it Sohcahtoa as an SOH, which stands for sine theta. Theta is our angle, is equal to the O for opposite divided by the hypotenuse. Okay, and that means the length of the side. Ka is CAH, same idea. Cosine theta is equal to the adjacent over the hypotenuse. And finally, TOA is tan over opposite and adjacent, TOA. Tan theta equals opposite side over adjacent. Okay, some great things to remember. And we also know Pythagoras Theorem, c squared being the hypotenuse. Okay, so c's hypotenuse is equal to one side squared plus the other side squared. And finally, all angles added up together in a triangle equal 180. Okay, I have two right angle triangles here. Theta is going to stand for my angle. The big problem is what is considered the adjacent, opposite, and hypotenuse each time. These things can change. One of them doesn't change. Do you know which one never changes?
Hypotenuse.
Hypotenuse. It's always what?
The longest side.
Longest side, which is always has to be opposite of our right angle triangle. So this will always be the hypotenuse. Okay. What would be considered the opposite side of this angle here?
The bottom.
The base, right? Yeah, the bottom here. This would be our opposite. What about on the other one?
The side, the right side.
Not the right, but the left side.
Oh.
Would be the opposite. So see how the opposite changes depending on which angle we're talking about. That's very important for setting up Sohcahtoa because we constantly talk about opposite and adjacent. And we can be referring to different sides at different times. And finally, adjacent means to be touching. Okay? Well, there are always two sides or two sides of a triangle touching an angle. That's how they create the angle. One of the sides will always be our hypotenuse, unless we're talking about 90 degrees, but we never are when we're doing this. Okay, so if this side is the hypotenuse, by deduction, what's the adjacent?
That right there.
Yeah, the other side, right? Just has to be. It's the only thing left. Which means, again, by deduction, this is the adjacent. So, depending on what angle, this is very important, depending on where our angle is, the opposite and adjacent sides, whoops, they change. Okay, so we have to keep that in mind. So let's say we're going to solve a question, and they've given us some information. Let's say they've given us a right angle triangle, and they've told us that the hypotenuse is 12. This side is 8. Okay, and they want you to find the other two angles. We'll call this one theta 1 and theta 2. Okay. Well, let's talk about theta 1. What sides of the triangle do we have measurements for?
Opposite side.
Uh-huh.
And
That's right. So opposite and hypotenuse.
Sine.
That's right. We're going to be using sine. So sine theta is equal to the opposite over the hypotenuse. What's the measurement of the opposite?
8.
8. Hypotenuse?
12.
12. Perfect. And what are we solving for here? Angle 1, or theta. So I'll highlight this. Now, the only thing is...
Are you going to do the inverse relation?
Exactly. To solve for the angle, we have to do the inverse relation. So really, we're going to get sine theta is equal to sine inverse, whenever we're looking for the angle, of 8 divided by 12. Okay, and let me see if I can take out my calculator and solve that. 8 divided by 12, and then my inverse for sine, 41.8. Okay.
Would that be 42?
Sure. Let's say approximately 42 degrees. Okay, great. What about for this one here? What sides of the triangle do we have?
The hypotenuse
and the adjacent. What ratio will we use then? Adjacent hypotenuse. Let's scroll up.
TOA 10.
Time gives us opposite and adjacent.
Oh, what did I say?
So-
Oh, I said cos.
Cos, that gives us adjacent and hypotenuse. So cos theta is equal to adjacent over the hypotenuse. What's our adjacent? 8 over
Go.
12, right? And again, we're looking for the angle, so we got to find the inverse of that function, right? So our answer is going to be theta is equal to cos inverse of 8 divided by 12. Well, that's really odd. It's the exact same ratio we had above. But this time we're doing cos inverse. So let's see, will we get a different answer? Cos inverse. 8 divided by 12. Cos inverse, 48.
Wait. Sine, cos, and tan. Do they each stand
For an equation. And each of them are a different equation. They're very in depth. Okay. So let's kind of write these in here. Let's double check. This became 48 degrees. All right, or approximately 48. And this became approximately 42 degrees. Okay. Well, let's make sure those all add up. Let's say we call this angle A, angle B, and of course angle C will be our hypotenuse, opposite of our hypotenuse, so our right angle. So let's add them all up. 42, I'll plug that in a second, plus 48, plus 90. What does that all equal? You want to take a calculator out and check that? It's right beside you.
Ah. $180.
180. Perfect. So, did we solve that correctly?
Yeah.
Yeah, it worked. Okay, well, let's say I wanted to find this side here. I have a lot of information. So what I'm going to do is I just want to make sure you know how to use the last ratio. Let's use tangent. Tangent, okay? And I got to figure out which angle I'm going to use here. Because I'm going to be looking for, if I'm looking for this angle, say I'm using this angle, this would be considered the opposite side, right? So that'd be tan 48 is equal to, we'll call it x. X's are unknown, divided by our adjacent, which is 8. Okay?
We multiply 8 on both sides.
Yeah, so it becomes 8 times tan 48 equals x. And let's get rid of the inverse. 48 tan times 8, 8.88. Okay. But I could have used the other angle. I could have used 42. For instance, I could have gone tan 42. What would we consider the opposite from here?
8.
And my adjacent would have been x. So that would have been actually 8 over x. Okay. And I can just kind of cross multiply, swap these. So this becomes x equals 8 over tan 42. That's how to isolate it. I just did that really quickly for the sake of time, okay? Yeah, so we have to do 8 divided by tan 42. So take out our calculator. Let's see if we get the same thing. 8 divided by brackets 42 tan is equal to 8.88. So it didn't actually matter which angle I used. As long as I plugged them in properly, I got the right answer there.